Hello, Maurits here. In this video we should look at the derivative and how to define that. And what is the derivative? The problem at hand is we have some kind of function, say, and we want to find some reasonable slope at the point or gradient at a point. Say we have an ST diagram and we would have something like this, a straight line. We would know that to find the velocity we take the change in s over the change in t. And our goal is to be able to do something similar for any kind of function f of x. So say we want to find the slope at some particular point at the value x. We pick a point a bit away, say I pick it up there, and then I draw the connecting line. Okay, my point would be over there instead. And the slope of this line will be our average velocity. X is now the time. So stands to reason that if I move this point more and more close to the other point, our slope would get closer and closer to the slope at the point, or the velocity at the very point, so to speak. We can look at a little bit of a GeoGebra file here where I've done basically the same thing. So I have some kind of function. In this case, f of x is x to the power of 2 divided by 4. I chose that one because it makes a nice graph to work with. And I have some value for x. Can move this part here. And I pick a point a bit away. Say we call the distance from x to that next point h. So the next point will be at the coordinate x plus h. If I plug in x to my function, I will get f of x. And if I plug x plus h into our function, we get f of x plus h. Now take the second point and move that closer and closer to the first point. We can see that it seems like this secant we have get closer and closer to something that we call the tangent line. The tangent line is the line that just touches the underline at that point. So if we imagine we would be at that point, the slope of the curve would be the same as the slope of the tangent line. So the red line here we call the tangent line, and the blue line is our secant between that and that point. And as we move this closer and closer, we should get better value for the slope. And that we will use in our definition. So basically, we draw this same figure. We have some kind of function. So this is our function f of x. We pick a point at x. We pick another point a bit away at x plus h. So the difference between these two, that is our delta x, that we will call h. And if I plug in x to my function, I get f of x. And if I plug x plus h into my function, I get f of x plus h. So the slope of the secant here will be change of y over change of x. And as we move the second point, this one over here, closer and closer to this one over there, our slope should get closer and closer to the slope at the point. And we will define the thing that is called the derivative as, and we write that as f with a little line like this. We call this f prime of x, and that is the derivative of f of x. And we define that as the limit, so the value we approach as delta x goes to 0 of delta y over delta x. By itself it's not so useful, but we will change this definition to something useful by saying, okay, how about we plug in our function things here. So now I take instead the limit as delta x goes to 0, that's the same thing as h goes to 0, of delta y, and delta y will be the difference of these two. So that will be f of x plus h minus f of x divided by delta x, that will be h. And that will basically be our definition of the derivative. And the derivative is now a function that gives us the slope of another function at every point we can find the slope. We have a bunch of different ways to write this. We can write it, as I said, as f prime of x. We can also write that as y prime. We can also write that as dy over dx, that is often read as just dy dx. We can see this just as a short form for the thing up here. So this one here is just a short form for this. All of these are just short form, but the reason it's written like this is because it should remind us that it's the derivative of y. And we say that it's derivative y with respect to x, and that is to say that y is our function, is calculated by our function. X is the independent variable that we will change. We can also sometimes write it as f of x, and then we put prime on it like this, and we'll see examples of that in the next video. So this is the basic definition. So far we haven't used it for anything, but we'll look at that in the next video. Thank you.